we're trying to find out why the data sets are so different with this counting the spikes. So if let's just focus on Y right now, on this Y data set, and we see that red was somebody that counted the spikes and watched by hand which spikes were being counted. And then these are the two class data sets that we're looking at, the Y set. So why is there such deviation? Let's look at the file and try to go over that. So if we look at this file, let's first look at it really small. We can crunch it down here, and we see start 1, 2, 3, and we see it's pretty noisy. The baseline's really moving a lot, but we see that we get some spikes here. We see some other spikes in the baseline, and then we go over to the data set that really caused us some issues. Here's 1, 2, and 3, and then we did a washout, and here's a 1, 2, and 3, and you can see the variation in the baseline and the spikes. Let's go and blow this up a little bit. Let's look right here. Let's go down here and extend this out. Try to get to the first one, which is right here. Okay, and let's see. So the spikes, you can change this amplitude here, and we see that we get some very large spikes. And then there's not these little spikes over here. There's a few, but you see that there's more of them in here. So it probably is really neural activity. It's probably the static sensitive cells that are firing. Okay, well, let's go up here and kind of get an idea of what we want to do for analysis. So we go to channel 2, cycle measurements, and we see our traces. This is the 26.5. Make sure this is right. This is 26.5. Yes, so we're right on. We can hide that little trace. Now we can see what spikes do we want to count. Then you can change the setting, right? And we can say, oh, let's just count the big spikes, for example. And so here's 26.5, so we know we have to go to 36.5. So if we scroll on down here to 36.5, this is where it ends. So what did we count in there? We counted, oh, there's one small one it counted. It's counted this large one, and it counted all these large ones. So that's a standard deviation of 3.5. Let's just look at see what that does. Go over here to auto scale, move our little marker up here at the beginning of this trace, and we go over, watch the time is up here. We're going to go over to 10 seconds. And 999, well, good enough for government work. It's not changing anyways. And we get 28 counts. So as you can see over here in this little circle, 28 counts. So there's 28 large spikes. Well, let's say we want to count these smaller ones. So what do? Let's click here just to make it show up there first. So 28 for the large ones. We can get rid of that. And now we can change the standard deviation lower. And we see that the smaller ones are beginning to come in. See those little circles up there? There we go. And if you want to blow it up a little bit to take a look, you can see, yes, we got all these little small ones that are just above that 60 cycle noise that's down there. And we get all the big ones too. But wow, it's getting some that are just barely above the noise. It would be nice to take the noise level and like double it. So you take that noise and you make it twice as large, and you would see you probably wouldn't count these smaller ones. You might get that one right at the limit of it. So usually about 2 times the size of the noise, the thickness of the noise is where you want to call it. So this one is a standard deviation of 1.6529. Let's see what we get here. So if we could do auto scale there, take the little M marker, and now move it on over here until we get to 10. Right there somewhere, we get 103. Okay, so either 27 large ones or 103 large ones plus these kind of larger ones that are out of the baseline. Now, if we scroll on over to, let's do the first one in this division. right here and see what's happening. So we click here. Let's expand this. And let's go back to that first one. That's the stop. And we see we got kind of these large ones again, and then these other ones. But let's keep the same standard deviation that we just used. And you see 49.5, 49.5. So we have to make sure it's matching. But look how many points it's counting here. And if we extend this out a little bit, we see that it's counting even the 60 cycle noise. But we kept the same standard deviation. Let's just see what it does. So we click there. We have auto scale here. We put the M here at the beginning of this trace. Okay, and then we go on over for 10 seconds. Well, we can crunch this up a little bit so we get 10 seconds. Let's do that. Auto scale. And let's find out where 10 seconds would stop. About there. And now we get 750. But when you look at it, it really isn't a larger number of these kind of spikes that are outside the noise compared to what we had in saline. And we still get a few of these, right? Maybe about 27, even if you go in and hand count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. About the same number, you know. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 6, 7, 8, 19, 20, 21, 22, 23, 24, 25, 26. Yeah, but you see what happened is that somehow it's counting a lot of the noise because the baseline's more wiggly. So what you have to do is to go in and change the settings, and that's really a pain. And go in there and probably say, let's get down to the noise level over here. Probably raise the standard deviation to maybe something around there. So it's got the spikes this time, but not the 60 cycle noise. And there it goes. You see it's getting the spikes, but not the 60 cycle noise. So if we wanted to count those spikes this time, we could. And let's see what it does this time. Let's move the marker over here at the beginning. Go 10 seconds over. And here we are at 10 seconds, and we get 114. So you see the difference of having to change the standard deviation to make sure we can still count these spikes, but not all the noise in there. And, you know, that 114 fits pretty well if we go back to one of these. You know, it's going to be, here's 100 in there. So we're back into this level. If we only wanted to count the large spikes, we would be down at 27, which would be down here. So we must be counting those spikes just above the noise in this data set. But in these two data sets, we're getting the 60 cycle noise that's inside of that those traces. It's because the baseline wiggles up and down so much compared to the baseline didn't wiggle as much in here. So the take home of this is to show that these automated analysis can really mess you up. And so you put this data up online like journals ask you to, and then somebody else goes in and analyzes it. And it almost doesn't make sense unless you have a movie or really detailed instructions that the noise changes on every setup or every run or trial, and that you really have to watch out that or count the spikes by hand from 2 times the noise level to make sure you get the right accurate numbers. So this is a good example of showing the automated analysis is not a great idea in this software. And you know, you assume it would be. You use the same standard deviation and you're using the same traces, same recording, but you can see how that could easily be messed up. Okay.